Hi everybody, welcome to tutorial 4. This is part 1 of 3. I hope that October where you are is as beautiful outside as October where I am. I hope that you had a good experience on the midterm, and if you did not, hopefully you can exceed your expectations on the next midterm and the final. Here is the content of the week. We'll talk about lists, anonymous functions, some of the more subtle points of the Lambda and Racket, and of course practice problems as always. When we talk about the fundamental structure of a list in Racket is kind of like a pair. There's a car and a cdr. The car can be anything. This is what you would see as the elements in a list, and the cdr is the end of the list. You can think of this as being the first element of the list, and the cdr as being the rest of the list. These are the only two lists that exist, the empty list, and then a list made with cons that contains car and a cdr. There are a lot of options available for making a new list, such as cons. You would use cons as you would use make node. This is the make node of the list world. Cons A and D makes a list with first element A and rest of the list D. List A, B, C, D, E does what you would expect it to. It makes you a list with the elements A, B, C, D, E in the order A, B, C, D, E. Append is a function that takes two lists and glues them together. And build list is one that you've looked at in lecture, and it's a really fun one because it builds the list containing 0 through n-1 and applies the function f to each of those numbers. Lists have several qualities, and there are built-ins corresponding to them. All lists have length. The length built in will output the length of that list, which is how many elements are in the list. Lists have an order. I've put an asterisk here because I'm not talking about the ordering that you might see as the BST invariant or the ordering on the numbers or the natural numbers, but order of first element to last element. And we can change the order using reverse. Lists have a very particular structure. You can use car to get the first element, cdr to get the rest of the list, and then cadr, cadr, cadar, and all of those other combinations of car and cdr that you've seen in lecture to help you navigate through a list. Lists have containment, and you can use the built-in member E of list to see if E is a member of a list. Of course, we can define other functions to use on our list, such as sum, snock, which was Professor Cormac's reverse version of cons, and doItList, list I and F, which is our naive implementation, our trial version of fold L. We're going to have a little fun this tutorial. Hopefully it'll be slightly more interactive. There's some work I have for you, and it is which of the following expressions throw errors. Try to think about this a bit, maybe pause the video and write down A, B, C, D, E, all the way through to part J, and indicate with a true or false whether you think a given expression will throw an error. I'll run through them quickly here. This one is a definition, and it says define proc1 for procedure 1, lambda x of empty. The next one, lambda xx plus xx, summing two x's. This next one, procedure 2, is lambda and then no arguments. This function outputs empty, the lambda outputs empty. Calling proc1 in brackets, calling proc2 in brackets. And then these ones are all different variations on accepting and summing parameters. This last one is using define to create something very similar to our option B here. Before we get on to the answers, which I'll show you in a minute, we're going to talk about exactly what a lambda expression consists of. So keep your paper or your answers in the back of your mind. We'll get on to those next. First, a lambda expression consists of a lambda itself, which signals to Racket that you're declaring an anonymous function, then some parameters p1 through pn, and then an expression. And you'll put those in this very specific order whenever you would like to use a lambda. So it'll be bracket to open your expression, lambda, some parameters in brackets, and some expression. The expression doesn't have to be in brackets if it's a value, such as 2 or empty, but otherwise you would call it as normal. Now let's get to the answers. Here they are. Maybe surprising, maybe not surprising. Procedure 1 runs, so you don't have to use x, the x that you defined in here. Procedure 2 does not run, and the reason for this is because, this is procedure 2. The second option, B, does not run because there's a duplicate parameter here. Bracket needs to know in this argument which x it is. You cannot name these two x's the same thing. Procedure 2 runs, you can have no parameters. That's possible, it's acceptable. And of course, bracket procedure 1 bracket does not run. And the reason for this is because it expects an x. You can see here that it's lambda x empty. Brackets procedure 2 does run because it doesn't expect any parameter. So this is how you would call, it looks kind of strange because there's nothing else inside of the expression with it, but how you would call a function with no parameters. Lambda xyz plus xy adds x and y. You don't need to use the z parameter. We throw away the z parameter. G is interesting. If you haven't figured it out, green corresponds to expressions that run and red corresponds to expressions that don't run. If you go into full bracket and type G, lambda xy plus xyz into your definitions window, bracket won't let you run it. It'll tell you the error beforehand. It'll say z is an unbound parameter. I don't know what to do with this z. However, if you run full bracket and you type this expression into the interactions window, it will output procedure. It won't detect that there's an error in this expression in the interactions window. You'll find out why a bit later, but you can think about it now if you want. This next one, of course, is applying this function to 3 numbers. And this is, of course, a legal application of the lambda. This is exactly just how you use a lambda expression. This one is the same as G, but it's red instead of yellow. Even in the interactions window, bracket will signal this as an error. The last one, very similar to part B, which was our other expression that didn't work, does work. You are allowed to define a function that has the exact same name as a parameter. I don't recommend it because it would be very confusing, but bracket gives you the option to do it. You may have been a little bit troubled by how some of these work, so we're going to try to dig in and get to the intuitions of how these lambdas work so that when we type them into our programs, we'll know if they work rather than having to hit run and see if they work in bracket. Digging a bit deeper into these lambdas, can you determine the output of the following expressions? So here I have a definition, define fun for function, not fun as an amusement, although it is also quite amusing. Fun, lambda x, and then the inner expression, lambda x plus x and 2 to the power of x. So we're going to sum x and 2 to the power of x. What happens if we call fun 4? What about fun 4, 5? Fun 4 of 5, and then fun of xion of 0. Make a little list on in your notes and write down what you expect the output to be. All right, hopefully you've written them down now, and I'm going to proceed to show the answers. When we run fun of 4, bracket outputs hashtag procedure. And what this means, or number sign procedure if you prefer, is that after running 4, it will output this lambda expression. So this is another procedure. It outputs a function. What about calling fun of 4 and 5? This outputs an error. It will say function parity mismatch. which happens because this lambda expression, the outermost lambda expression, only expects one parameter, and we're giving it 2 parameters. Think about this next one. We already saw that fun4 outputted a procedure, so we're applying the procedure from fun4 to 5. And the question is, these parameters are both named x. Which parameter does Racket substitute in for which x? Does it substitute in the innermost x, the outermost x? Will it substitute in 4 here and 5 here, or 5 here and 4 here? Try to think about that. Pause the video if you need. Try to make a prediction and try to write down a justification. If you were Racket, which value would you use and why? Racket outputs 37. As you can see, that is using 5 as this x and using 5 as this x as well. It's 5 plus 32. It appears that we've thrown away the value 4. What about function of 0? Well, the same thing happens. We throw out the string shun and use the value of 0 here, sum of 0 and 2 to the 0, which is 1. So that may be troubling to you to find out that we throw away one of our parameters, even though it's also called x. It appears that Racket just takes the innermost parameter. It appears that in this expression, these two x's are bound to this x, whereas this x is simply thrown away. If this is disturbing to you, hold on, it's about to get a lot weirder. Can you predict the output of the following expressions? This first expression, we're checking for equality between 1 and lambda of empty of 1. Lambda empty of 1 always outputs 1, and 1 always outputs 1. If things are judged on equality by their output, we should expect these two to be equal. However, they're not judged on equality by their output. This expression is a procedure, and this is a value. They're not the same thing, sadly. What about this one? Equal, lambda y of y. This is an anonymous function that takes in any parameter and outputs that same parameter that it just took as input. This is another one. It's a function that takes in one parameter and outputs it outputs 1 plus -1 plus y. It outputs y. These two should both output y. So are they the same? Again, no, they're not the same. Of course, this function will run regardless of what you pass as input, and this function will only run if you pass a number as input. What about these two expressions? Equal, lambda y of y and lambda x of x. Does it matter what the parameters are named? In practice, if you gave either of these functions something and it gave that something back to you, you wouldn't be able to distinguish which one was being used. So if equality is judged by function, these two would be exactly the same. However, it is not judged by function. Interestingly enough, these two expressions are not the same. Now, if all of this stuff struck you as weird, or if any of it struck you as weird, particularly the last one, the result of 4 should be even more troubling. Equal, lambda x of x with lambda x of x will output false in the full Racket. Why is this? Even though we typed the exact same expression in, they can't be equal? Well, this x is bound to this x of this lambda, and this x is bound to this x of this lambda, and lambda. They're two different x's. It is possible. You might be thinking, is it even possible to compare two lambdas and get the same thing? Are all lambdas fundamentally different? And the answer to that is no, I can get this. Not all lambdas are fundamentally different. I can put in two lambdas and get them to output equal, The way to do it would be to use a lambda with the same x, one could define, right, define f, for example, just choosing a random variable name, define f to be lambda of x, outputting x, and then if you compared f and f, bracket would output true. Hopefully, you have been able to develop some more intuitions about how lambdas work in Racket. I've got some practice problems as always. The formatting is a little clustered, but it's not as much work as it appears based on the full text of this slide, so I'll go into detail and explain it a little bit. Our goal is to rewrite the following functions using a lambda. Power list of x and n is going to make a list of the powers of x from 1 to n. We're not including 0 here. I've implemented power list recursively using a tail recursion. Power list help is the last thing that gets called in power list help. If n is less than 1, we'll return our accumulator. Otherwise, we will call power list help of x 1 less than n, and we will add, using cons, which we learned about in the start of this video, x to the power of n to our accumulator. My 3 problems to you are as follows. 1, write map square map add 1 build list 10 square using only one call to build list. The idea here is that we can outsource all these different functions into one lambda. So see if you can do that. The next one is to rewrite power lists in 2 different forms. One is as a lambda that takes in the same parameters, and the second version is to use 2 lambdas, one for the first parameter and one for the second parameter. The benefit of power list 2 is that we can pass in n and say n is 5, and then pass in many different x's to the output of my power list 2. I hope that you try the problems. I hope that you have enjoyed this video. Thanks for watching and have a great reading week. I will see you in part 2 of the tutorial video.